Hello, in this lecture we'll find out the area of a square. In the drawing we have the right triangle ABC, and we know that side AB equals to 5 units, side BC from the right triangle ABC equals to 12 units, angle ABC equals to 90 degrees. Inside the right triangle ABC we have this square DEFG, and our mission is to find out the area of this square DEFG. Okay, so first of all we will implement the Pythagoras theorem on the right triangle ABC. So in the right triangle ABC, here by PT is the relation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle ABC is AC, therefore the square of the hypotenuse is AC square. And it must be equal to AB square plus BC square. Okay, again in the right triangle ABC, according to the Pythagoras theorem, AC square equals to AB square plus BC square. So AC square, this is the square of the hypotenuse, equals to AB square. AB is 5, therefore AB square is 5 square, that is 25, plus BC square. BC is 12, therefore BC square is 12 square, that is 144. In conclusion, we found out actually that AC square equals to 25 plus 144. 25 plus 144 is 169. So we found out that AC square equals to 169. Here we take out of this equation and finally we get that AC equals to the square root of 169, that is 13. AC equals to 13 units in its length. So therefore AC equals to 13 units. In the next step, we'll define this angle as angle alpha, and we'll focus on the right big triangle ABC. On the right big triangle ABC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. Well, because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees, that is the sum of the angles in any triangle. Therefore, the missing angle here must be equal to 90 degrees minus alpha. So we define 90 degrees minus alpha as beta. And therefore, the missing angle here must be equal to beta. We have also the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Again, the sum of the angles on one side of a straight line is equal to 180 degrees. So we can implement the the one that I mentioned in our drawing. Why? Because in our drawing we have the hypotenuse AC. AC is an hypotenuse, or as one side of a triangle. It is absolutely a straight line. So AC is a straight line. So if you focus on the lower side of the straight line AC, it's point D here. So here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC at point D? We have this angle that is 90 degrees plus the missing angle here. In total, they must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle here must be equal to 90 degrees. In order to complete the sum of the angles at the lower side of the straight line AC at point D 280 degrees, the missing angle here must be equal to 90 degrees. Likewise, if we focus on the lower side of the straight line AC at point E here. Here, the sum of the angles must be also equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC at point E? We have this angle that is equal to 90 degrees plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle must be equal to 90 degrees in its size. So, we focus on the small right triangle, triangle ADF. In the small right triangle, triangle ADF, this angle equals to beta, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus beta. But here, we know that 90 degrees minus alpha equals to beta. So if we add to this equation alpha and then we subtract beta, we get that 90 degrees minus beta equals to alpha. Degrees minus beta equals to alpha. And found out that the missing angle here is equals to 90 degrees minus beta. Okay? And we just right now found out that 90 degrees minus beta equals to alpha. Therefore, the missing angle here equals to alpha. In the next step, we focus on the right triangle GCF. On the right triangle GCF, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta. And therefore, the missing angle here equals to beta. In the next step, we will focus on the upper side of the straight line BC at point G. So which angles we have at the upper side of BC at point G? We have this angle is equal to beta, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles on the upper side of the straight line BC at point G. Therefore, the missing angle must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha. Therefore, the missing angle here must be equal to alpha. Okay. And finally, we focus on the right small triangle, triangle FBG. In the right small triangle, triangle FBG, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, and therefore, the missing angle here must be equal to beta. So, actually, we found out that all the angles in all the triangles, they're actually equal to each other. In each triangle, we have three angles that are alpha, beta, and 90 degrees. So in total, we have in the drawing 4 triangles. 1, 2, 3, and the big triangle, triangle ABC. So we have in the drawing 4 right triangles, and in each triangle, the angles that we have in each triangle are alpha, beta, and 90 degrees, and therefore we can say that the 4 right triangles that we have in the drawing are similar to each other according to angle similarity rule. Okay, they are similar to each other according to angle similarity rule. For example, the big right triangle ABC is similar to this small triangle, triangle FBG. So I write it down. The big right triangle, triangle ABC is similar. This is the sign of similar. Is similar to the right small triangle, triangle FBG. And from the fact that the big triangle ABC is similar to the small right triangle FBG, we will derive that the following relationship exists between the sides of the two triangles that are similar to each other. But before that, we define the length of this side BG of the right triangle FBG as x. So what is the length of side BC? For the drawing, it is very easy to see that BC equals to B. What is the length of GC? This is side GC. So what is the length of line 7 GC? From the drawing, it is very easy to see that GC equals to BC minus BG. Again, BC minus BG equals to GC. So GC equals to BC, that is 12, minus GC, that is x. So in total, found out actually that GC equals to 12 minus x. In the next step, we define the side length of one side of square DEFG as L. So DE equals to L, and therefore all the other three sides must also equal to L, because of the fact that we know that all the sides of any square are equal to each other in their lengths. Okay. So we found out actually, we know that the right big triangle ABC is similar to the right, this right small triangle, triangle FBG, according to angle similarity rule. And for the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We will derive that BG over FG in the right triangle FBG is equals to BC over AC in the right big triangle, triangle ABC. I repeat again, we derive that BG over FG in the right triangle FBG equals to BC over AC in the right triangle, triangle ABC. So BG is x over FG. FG is L. BC is 12 and AC is 13. So in conclusion, found out that according to equation 1, x over L equals to 12 over 13. Here we multiply this equation 1 by L, and we get that x equals to 12 over 13 times L. Okay, found out that according to equation 1, x equals to 12 over 13 times L. Likewise, we also know that the right big triangle, triangle ABC, is similar to this right triangle, triangle EGC. Repeat again, we know that the right big triangle, triangle ABC is similar to the right triangle, triangle EGC. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that GC over EG in the right triangle, triangle EGC is equals to AC over AB in the right triangle, triangle ABC. Repeat again, we derive that GC over AG in the right triangle, triangle EGC is equals to AC over AB in the right triangle, triangle ABC. So GC is 12 minus x over GE. GE is L, and it is equal to AC. AC is 13 over AB. AB is 5. In conclusion, we found out that according to equation 2, 12 minus x over L equals to 13 over 5. Here we cross multiply this equation, equation 2, and we get that according to this equation, equation 2, 5 times 12 minus x equals to 13L. So here we'll open the brackets on this side of equation 2, and you get that according to this equation 2, 5 times 12 is 60, and 5 times minus x is minus 5x, that is equals to 13L. So here we get 5x and then we subtract 13L simultaneously from this equation, equation 2, and we get that 60 minus 13L equals to 5x. So according to equation 2, 60 minus 13L equals to 5x. So we have x in this equation, equation 2, and we already found out that x according to this equation, equation 1 equals to 12 over 13L. So we can substitute x in this equation, equation 2, by the value that we found for L in this equation, equation 1. So we do it now, we get that 60 minus 13L equals to 5 times x, and x equals to 12 over 13 times L according to this equation, equation 1. So according to equation 2, we actually found out that -60 minus 13L equals to 5 times 12L over 13. 5 times 12 is 60, so actually that 60 minus 14L equals to 13 to 60 to 60L over 13. Okay, so here we'll multiply this equation 2 by 13, and we get that according to this equation 2, 60 times 13 is 780, minus 13 times minus 14L is minus 169L, and this is equal to 60L. So here we'll add 169L to this equation 2, and we get that according to equation 2, $780 equals to 169L plus 60L, it is equals to 229L. So here we divide this equation by 229, and we get that L equals to 780 over 229. 780 over 229 is equals to 3.406,113. So if we found out that L, that is the length of one side of square DEFG, is equals to 3.406,113 units, and the area that we're looking for is the area of square DEFG, and the area of any square is equals to the length of one side squared. The length of one side in our square DEFG is L, and therefore the area will be equal to L squared. And we outside now found out that L equals to 3.406,113. So here L squared will be equal to 3.406,113 squared. 3.406,113 squared equals to 11.6016. If we found out that the area of square DEFG is equals to 11.6016 square units. Okay, and that is actually the answer to the question. Repeat again. The area of this square DEGF is equals to 11.6016 square units. So in the next step, I will summarize the lecture. In this lecture, I found out the area of this square DEFG. So in the drawing we have a right triangle, triangle ABC is a right triangle. Side AB of the right triangle ABC equals to 5 units in its length, side BC equals to 12 units in its length. Inside this right triangle ABC we have this square, and our mission is to find out the area of this square. So first of all, we implemented the Pythagoras theorem in our right triangle, triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse on the right triangle ABC is AC, therefore the square of the hypotenuse is AC square, and it must be equal to AB square plus BC square. Repeat again, in the right triangle, triangle ABC, according to the Pythagoras theorem, AC square equals to AB square plus BC square. So AC square, that is the square of the hypotenuse, equals to AB square. AB is 5, therefore AB square is 5 squared, that is 25, plus BC square. BC is 12, therefore BC square is 12 squared, that is 144. In conclusion, found out that AC square equals to 25 plus 144. 25 plus 144 equals to 169. In conclusion, found out that AC square equals to 169. Here we took out of this equation and finally found out that AC equals to the square root of 169, that is 13. So here the length of this hypotenuse AC is equals to 13 units in its length. Okay, in the next step we define this angle, it is actually angle ACB, we define angle ACB as alpha. And then we focus on this, the right big triangle, triangle ABC. On the right big triangle, triangle ABC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. But we defined 90 degrees minus alpha is beta, and therefore the missing angle here equals to beta. Okay? And then we have also the rule that the sum of the angles on one side of a straight line is equals to 180 degrees. Again, the sum of the angles on one side of a straight line is equals to 180 degrees. AC is the hypotenuse of the right triangle ABC. AC is the hypotenuse, must be a straight line. So AC is a straight line. So if you focus on the lower side of the straight line AC here at point D, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC at point D? We have this angle that is 90 degrees, plus the missing angle. In total it must be equal to 180 degrees. Therefore the missing angle must be equal to 90 degrees in its size. Likewise, if you focus on the lower side of the straight line AC here at point E, at the lower side of AC at point E, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC at point E? We have this angle that is 90 degrees, plus the missing angle. In total it must be equal to 180 degrees. Therefore the missing angle here must be equal to 90 degrees in its size. Okay, then we focus on the right triangle, triangle AFD. On the right triangle, triangle AFD, this angle equals to beta, this angle equals to 90 degrees. Therefore the missing angle must be equal to 90 degrees minus beta. According to our definition, 90 degrees minus alpha equals to beta. So if you subtract beta and add alpha to this equation, you will get that 90 degrees minus beta equals to alpha. And we just right now found out that the missing angle here in the triangle ADF must be equal to 90 degrees minus beta. But we just right now found out that 90 degrees minus beta equals to alpha, therefore the missing angle here must be equal to alpha. And in the right triangle EGC, this right triangle EGC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, therefore the missing angle here must be equal to beta. Okay, and then focus on the upper side of the straight line BC at point G. Again, at the upper side of the straight line BC at point G, the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of BC at point G? We have this angle that is beta, this angle equals to 90 degrees, plus the missing angle. In total, the sum of those three angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle here must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles on one side of a straight line. Therefore, the missing angle here must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha, therefore the missing angle here equals to alpha. And in the next step, focus on the right small triangle, triangle FBG. In the right small triangle, triangle FBG, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, therefore the missing angle here must be equal to beta. So actually, have in the drawing 4 right triangles. 1, 2, 3, and the big right triangle, triangle ABC. In total we have 4 right triangles in our drawing, and all those 4 right triangles are similar to each other according to angle similarity rule. Why? Because each triangle, each right triangle in our drawing, each right triangle has 3 angles, alpha, beta, and 90 degrees. Actually, all the 4 right triangles have exactly the same 3 angles, alpha, beta, and 90 degrees. Therefore, all those 4 right triangles are similar to each other according to angle similarity rule. For example, the big right triangle ABC is similar to the small right triangle, triangle FBG. Repeat again, the big right triangle ABC is similar, this is the sign of similar, to the right small triangle, triangle FBG. According to angle similarity rule. And from the fact that the big right triangle ABC is similar to the small right triangle FBG, we derive that the following relationship exists between their sides. We will derive that side BG over FG in the right triangle FBG is equals to side BC over AC in the right triangle ABC. Repeat again, we derive that BG over FG in the right triangle FBG equals to BC over AC in the right triangle, triangle ABC. Why? Because those 2 right triangles are similar to each other. So BG is X, GF is L, BC is 12, and AC is 13. In conclusion, found out that according to equation 1, X over L equals to 12 over 13. Here we multiply this equation 1 by L, and finally found out that X equals to 12 over 13 times L. Likewise, we have the right big triangle, triangle ABC is similar to this right triangle, triangle EGC. Again, the right big triangle ABC is similar to the right triangle EGC. The right big triangle ABC is similar to the right triangle, triangle EGC. And therefore, the following relationship exists between their sides. They are similar to each other according to angle similarity rule, and therefore the following relationship exists between their sides. So, side GC over EG in the right triangle EGC is equals to AC over AB in the right triangle, triangle ABC. Repeat again, from the fact that the big right triangle ABC is similar to the right triangle AGC, we derive that GC over AG in the right triangle AGC equals to AC over AB in the right triangle ABC. GC is 12 minus X, EG is L, AC is 13, and AB is 5. So in conclusion, we found out that according to equation 2, 12 minus X over L equals to 13 over 5. Here we cross multiply this equation 2, and finally found out that according to this equation 2, 5 times 12 minus X equals to 13L. So here we open the brackets of this on this side of this equation 2, and found out actually that 5 times 12 is 60, 5 times minus X is minus X. So 60, in this side of the equation we have 60 minus 5X, that is equals to 13L. So 60 minus 5X equals to 13L according to this equation 2. So we have 60 minus 5X. We have X in this equation 2, and we have already found out that according to this equation 1, X equals to 12 over 13 times L. Therefore, we can substitute X in this equation 2 by the value that we found for X, this equation 1. We did it, and we found out actually that according to equation 2, 60 minus 5X. Here we have, but before that, actually, we just subtracted 13L, and we added 5X to this equation 2, and found out that according to equation 2, 60 minus 13L equals to 5X. Now, we substitute X in this equation 2 by the value of X that we found here, this equation 1. According to this equation, X equals to 12 over 13L. Therefore, we can substitute X in this equation 2 by the value that we found for X in this equation 1. We did it, and we found out actually that according to equation 2, 60 minus 13L equals to 5X, and X equals to 12 over 13L. Therefore, we substitute X by 12 over 13L. So we have here this equation 2, 60 minus 13L equals to 5 times 12L is 60L over 13. So we found out that according to equation 2, 60 minus 13L equals to 60L over 13. Here we multiply this equation 2 by 13, and finally found out that 60 minus 13 is 780, and 13 minus 13L equals to minus 169L, and it is equals to 60L. So here we added 169L to this equation 2, and finally found out actually that 780 equals to 169L plus 60L equals to 229L. In conclusion, found out that according to this equation 2, 780 equals to 229L. Here we divided this equation 2 by 229, and finally found out that L equals to 780 over 229. Okay? And 780 over 229 equals to 3.40611 units. So we found out the value of L. And what is the area of any square? The area of any square equals to the length of one side squared. The length of one side, according to our definition, is L, and therefore the length square is L squared. In conclusion, we found out that the area of triangle ABC is equals to L squared. We just write down found out that L equals to 3.40611 square units. So we put the data inside this equation in order to find out the area of the triangle. So L equals to 3.40611 square units, and therefore L square equals to 3.40611 free squared. and 3.406113 square is equals to 11.6016 square units. In conclusion, found out that the area of this square DEGF is equals to 11.6016 square units. Okay, thank you very much.